Some of you might already know this question, but some of you may not. So let me take some time to explain what I want to ask. I mean, what I want to show in this video, through this video. Anyway. So assume there's a straight road of a distance or a displacement, you may say, of 2 pi with capital R. And you also have a circle which is barely like holding itself on this straight road with its center just lying above the edge of edge on the one of its sides, and also say its radius is r, smaller in this case. So I can ask, like, what is the number of revolutions that this circle uh, needs to uh, cover so as to like go from here to here, like to cross this straight road. You can say, you will say obviously that obviously it's like r by r, right? R by r revolutions. uh, but my question is not exactly this. Like, if I take this straight road and I like join it end to end so as to form uh, let me change the color, so as to change so as to form a circle, and then I keep the smaller circle as it is, like at, in one of the uh, wait at some theta, I mean, and the radius of this one is r, and the radius of this one is capital R. So now I say, if I take it along this curve over it by rolling it purely and back to the same position where its center started, uh, what would your answer be to the same question that I asked in this case, that the number of revolutions that this little circle has to take? Now, if you say it's the same like r by r, then you're wrong. But if you say it's r by r plus 1, then you're correct. So the goal of this video is to prove where did this 1 come from. Like, if you see it like this, uh, it's like, okay, I mean, when I first saw this question, I was not like I said that the answer is like r by r, but I was shocked to find that it's r by r plus 1. That's not that intuitive. I mean, you need to be a genius to actually see it in the first go that it's r by r. It's like more than r by r or less than r by r. I mean, yeah, more to see that is more than r by r. Like, it's really a tough task. I think most of the people who see this question in the first round would say that it's capital R by a small r, as the case with most of us. So now let me just go back and try to prove like physically as why this is true. And I've not yet like known the intuition part of this. I think I will get to the intuition for this particular questions after some time, but I still don't have any intuition for it. Like, I have an intuition, but vaguely. I mean, it has not solidified it yet in my mind. I need some time for that. And if I ever get a solid intuition, like feel for the actual answer, like capital R by small r plus 1, I will not hesitate to make a video and post it. For now, bear with me for the physical part. I mean, using physics and solving it. Suppose this is our reference circle, and this is rotating with a, and this and the center of the bigger circle is assumed to be constant. I mean, I have assumed it to be constant. And about the center, the smaller circle center is rotating it at a constant angular velocity, that is omega to be precise. Uh, Now, the velocity of the center of this smaller circle can be written as not the velocity. I'm writing the speed, omega into r plus r. Obviously, because the distance of these 2 points is like r, sorry, r plus r. So this is the velocity that the center of the small circle has. I mean, this is speed. Now, for the smaller circle to purely roll about the center of the bigger circle, the velocity, that the speed that it possesses must be equal to the omega about its own axis. I say that as omega dash into, this is not dot, mind you, precise, into small r. Now, why is this true? Like, this is true because uh, when we say it's like rolling purely, we assume there is no slipping right here. So, no slipping. And when we say no slipping, the velocity of this portion of the smaller circle needs to be 0. So, uh, with respect to the center of this circle, if we say that it has omega dash at its angular velocity with respect to the center, the velocity of this part would be omega dash into r. And then again, the center is itself rotating with a velocity of this much. So if they turn out to be equal, they will cancel each other, and the velocity at this point will be 0 for the rim particles. And that is what I have exactly intended in this, through this equation. I mean, doing so, we get omega dash as omega plus 1 plus r by r. I guess you uh, uh, can see what I will do next. What I will do next is, when this completes a full circle, uh, it has traveled an angle of 2 pi, right, to 2 pi radians. And to travel and to travel through 2 pi radian would mean a time of 2 pi by omega. And when we multiply this in this equation, what we get is the number of rotation that this smaller circle has completed about its own axis. I mean, the angle that it has covered. When we do this computation, we get the angle that is it has turned as 2 pi into 1 plus capital R by R. And remember, we need the number of rotations, right? So we can divide theta by 2 pi because each rotation consists of 2 pi radians. Now what we get is revolution is equal to 1 plus r by r, mind you, number of revolutions. So yeah, this was my proof. And if I, as I said, if I get a solid intuition for this problem, I will not hesitate to share it. Thanks. See you in the next video.